In this presentation, we will like to present about instrumentation and process control system, introduction to process control and instrumentation. Process. Process as used in a process control and process industry refers to the method of changing or preparing raw material to create end products. Process industry include chemical industry, oil and gas industry, food and beverage industry, pharmaceutical, water treatment, power industry, and extra. Process control. Process control refers to the methods that are used to control process variables when manufacturing a product. In the act of controlling a final control element to change manipulate variable to maintain the process variable at the desired set point. Manufacturer controls the production process for three reasons: ensure safety, increase efficiency, reduce variability. Control theories basics. Control loops in the process control industry work in the same way. Requires three tasks to occur: measurement, comparison, adjustment. This is about all control theories. In many different instrument devices may or may not be used in control loops like transmitter, sensors, and extra. This is a simple control loop example. In this example, we see about the level controlling system by using level transmitter. Basic element of process control. Controlling a process requires knowledge of four basic elements: process, sensor, final control element, and control. This is basic elements of.
Okay, what we have here is we have a system set up. We used a pressure sensor to indicate a level. And so it's our level transmitter, and it sends a signal to the PLC, and it senses a pressure here from the level of the water and converts that into a signal, and then that does all the thinking, and when it comes back it sends a signal to this pressure transducer to changes an electrical current into a pressure, which is supplied from our air supply here. And then that pressure output gets sent to this control valve, and you can see the pressure right now is about 7.5 psi, and so the pressure then pushes down on this needle, which controls the valve, and you can see the indicator level is a little less than 50% there, which permits a certain amount of water to flow through there to maintain a level.
Right now we got the set point on the controller set for 50%. The range on the transmitter is 0 to 40 inches. So what's 50% of 40 inches? 20. So we're right there. We're slightly off. It's actually not an issue with the controller. Our transmitter. So this is kind of a cool setup because it's actually controlling something real. The other labs you've been building don't have a real process to hook to. It's just you have a transmitter, a controller, and a valve. This is actually controlling an actual process. So what I'll have you do is group around the PLC where you can see the screen, how we change the set point.
Process control terms. As any field, process control has its own set of common terms that you should be familiar with and that you will use when talking about control technology. Process variable. A condition of process find a liquid or gas that change the manufacturing process in some way. Common process variables include pressure, flow level, temperature, density or acidity, and alkalinity. Set point is a value for a process variable that is a desire to be maintained. Measured variable is a condition of the process, field, or resource that must be kept at the designated state point. Manipulated variable is the factor that is changed to keep the measured variable at a set point. These are examples. There is process variable, a set point in the control, and manipulated variables. Error is the difference between the measured variable and the set point and can be either positive or negative. Magnitude, duration, and rate of changes. In this graph, we will see some basics: duration, rate of change, and magnitude of error. Offset is a sustained division of the process variable from the state point. A load disturbance is an undesired change in one of the factors that can affect the process variable. A control algorithm is a mathematical expression of a control function. In this picture, we use some control algorithm by mathematical expression. A closed loop exists where a process variable is measured, compared to the set point, and action is taken to correct any deviation from set point. An open loop exists where the process variable is not compared, and action is taken not response to the feedback on the condition of the process variable, but is instead of taken without regard to process variable and condition. Manual control and automatic control. Mode of closed loop control. Closed loop control can be manual, on-off, PID, advanced PID like ratio, cascade, feedback forward, or model-based depending on the algorithm that determine instrumentation. Instrumentation is a technology of measurement which serves science, energy, medicine, and extra. Instrument is a device for determining the value or magnitude of a qualitative variable. Instrumentation function and advantage: indicating, visualize the process; recording, observe the step and the measurement reading; controlling, to control measurement and process.
What is instrumentation?
It's a career in oil and gas and other measurement-intensive industries.
It's the power to control mechanical operations for an entire facility.
It's collaborative, working with groups to diagnose problems.
It's the precision to make meticulous changes that could impact the world.
It's your future, with new technologies requiring new, young talent. A worldwide job on the cusp of change in technology, instrumentation is a field in high demand, and with SAIT's Instrumentation Engineering Technology Program, a career in the field is just a turn of the dial away. Instrumentation engineering encompasses the design and configuration of automated systems. You'll be the one responsible for measuring, recording, and controlling on-site variables, like flow, temperature, and pressure. The entire plant will depend on your precise metering.
Primary elements. In all cases, some kind of instrumentation is measuring change in the process and reporting a process variable measurement. Example of primary elements: pressure sensing diaphragm, resistance temperature detector, thermocouples, or fuse plates, pitot tube, Venturi tube, magnetic flow tube, Corliss flow tube, radar emitter and receivers, ultrasonic emitter and receivers, Anubar flow elements, vortex shader, transducer and sensor. A transducer is a device that converts one form of energy to another. For example, inside the capacitance pressure device, the transducer converts change in a pressure into a proportional change in capacitance. A sensor is a device that has a characteristic that changes in a predictable way when exposed to a stimulus it was designed to detect. Here we will see some sensors and transducer as instruments, and there should be a controller. And also here we will see transducer as a part of the controller and sensor as a part of instrument. Transmitter. A transmitter is a device that converts a reading from a sensor or transducer into a standard signal and transmits that signal to a monitor or controller. Transmitter types include pressure, flow, temperature, level, analytic transmitters. Signals. There are three kinds of signals that exist for the process industry to transmit the process variable measurement from the instrument to a centralized control system. One, pneumatic signal. Two, analog signal. Three, digital signal. Pneumatic signal are a signal produced by changing the air pressure in signal pipe in proportion to measure change in a process variable. The most common standard electrical signal is the 4 to 20 milliampere current signal in analog signal. Digital signals are discrete level of values that are combined in specific ways to represent process variables and also carry other information such as diagnostic information. Controller. A controller is a device that receives data from the measurement instrument, compares that data to program set point, and if necessary, signal a control element to take corrective action. Local control are usually one of the three types: pneumatic, electrical, or programmable. Here we will see some control types: pneumatic or electronic control, electronic, corrective final control elements. The corrective or final control element is the part of the control system that acts to physical change in manipulated variables. Actuators are often powered pneumatically, hydraulically, or electrically. Diaphragm, below, spring, gears, hydraulic fluid, valves, piston, or electrical commands. What instrumentation properties affect the process? Some instrument properties that affect the performance of your control system include the instrument range and span, the resolution of the measurement, the instrumentation accuracy and precision, the instrument's dynamics. Resolution is the smallest amount of input signal change that instrument and detect reliable. The larger your instrument span, the lower the resolution of your measurement. Precision is the reproducibility with which repeated measurement can be made under identical conditions. Here in this graph you will see precision, accurate temperature, and imprecision. Instruments have dynamic property, just as process do. The dynamic property instrument process are identical to process dynamics. Gain, time constant, and dead time. The gain of an instrument is often called sensitivity.